Okay, so this video is an introduction to histograms and also an introduction to how to draw a histogram. So let's get straight into it. So what actually is a histogram? A histogram is very similar to a bar chart, but there are some pretty key and subtle differences. Right, so if we look at a bar chart to begin with, hopefully a bar charts that you've been seeing since probably back in primary school, right? A bar chart looks something like this. Okay, so you've got some different categories here. We've got sports, cricket, football, hockey, and rugby. Okay, and we've got some frequencies, which just tells you like there are 4 people that play cricket, 3 that do football, so on and so forth. Okay, and with a bar chart, there are some pretty distinct features, which we'll see on the next slide, but just briefly, right, with the bar charts, all of the sports here, they have the same width here, so they're all just the same width, which is really important. And also there is a gap between each of the sports. If we look at a histogram, okay, a histogram this time does not use single values, right? So a bar chart had single values like 4, 3, 6, and 1. Single values, I mean, this is just like one sport, so cricket, football, hockey, and rugby, whereas here we have varying values. So what I mean by that, as we can see here, we're saying that the height of whatever it is here is between, this just means it is between 130 and less than 140. We've then got between 140 and 145, 145 and 150, so on and so forth. Okay, so continuous data means that the values, they can vary between 130 and 140. And also notice, right, that and we call it the class width of these heights here. For the first one, right, you've got a difference between 130 and 140 of 10. Okay, this one, it's a difference of 5, right? So unlike the bar chart, these widths of the bars vary with the histogram. Okay, so we can literally see on the first one, we've got between 130, which is here, and 140, which is here. The second one is a smaller width, which goes like this, okay, which is a really important point that we'll get onto in a second. So yeah, there are some really important differences between a bar chart and a histogram. So a bar chart, the heights of the bars, okay, represent frequency. So how many? So for example, there are 3 people that play cricket. There are 4 people that play football. The bars are equal width. That's really important. So we can literally see, right, the width of these bars, they are all exactly the same width, which is really important. Whereas a histogram, right, this time, this is really important, the area of the bar represents frequency. And the reason for this being is, right, unlike a bar chart, because, right, the width of the bars can vary with a histogram. So we can see here the widths are different. If you just put frequency on the y-axis like we did over here, it wouldn't really be representative, because like if you had a really wide bar, like this one here is wider, it starts to look a bit disproportionate if you just plot the width of it with the frequency. So to make up for that, we say that the area, okay, represents frequency. So pretty much to find how many people there are or how many things there are, you've got to go and find the area of each of those bars. And that's a really important feature with histograms. And the bars are not equal width, which we just mentioned, because the data has varying values. Okay, so that's some really key features of differences between histograms and bar charts. Okay, also another key feature is that all of the bars are connected in a histogram, which they're not with a bar chart. And the y-axis, we've got this new term, which is called frequency density, and we'll see what that really means in the next slide. Okay, so let's now look at drawing a histogram. So we've been given some data here, the speed of whatever it is, okay, with some continuous data, so varying between 2 values. And just remember these key points here. Remember the area of the bar represents frequency, and the y-axis is always frequency density, which they've plotted for us already, which is nice. Okay, well, to begin with, we need to get the class widths of each of these intervals here, okay, because we want to go and plot those onto our speed part of the graph down here. So the width of the first one, difference between 60 and 65 is 5, 65 and 70 is also 5, 70 and 80, we've got a different width of 10, and 80 to 100, we've got a width of 20. So these values here, 5, 5, 10, and 20, these are called your class widths, how wide your intervals are. Okay, and then we need to calculate our frequency density. Okay, and the formula for frequency density is this, which is frequency, okay, so this one here, divided by your class widths, so these values over here. Okay? And the reason, right, this really comes from the fact that if we rearrange this, which we won't get into now, but if I times through by class width, I will get frequency density, so let's call it FD, frequency density. If I times through by my class width, that is equal to my frequency, which is just basically saying that the area of the bars is these two times together. If that confuses you, don't worry for the time being, because we'll get into that anyway. So frequency density of the first one is going to be, well, the frequency, which is 15, divided by the class width, which is 5, which is equal to 3. And then we've got 25 frequency divided by your class width, which is 5, which is going to be 5. And then 36 divided by 10, 3.6, which is no problem. And your last one, 24, your frequency divided by your class width, 20, gives you 1.2. So these are the values of frequency density that we can go and plot onto our y-axis, this axis here. Okay, and then we need to kind of get these onto here, so let's go and choose some suitable increments. So if we go up every 4 squares as 1, so 1, 2, 3, 4, and then 5, and then we can begin to plot our histogram. Okay, so the first one, we're going between 60 and 65. So I've drawn a line. This point here is the point 65. Okay, let's go and label it in to make sure we are okay with that. Let's use a pen, not a highlighter. So 65. And the frequency density at that point there, okay, is equal to 3. Okay, so 3 is our frequency density. Let's go and plot that in. There we go. That's our first one done. The second one is between 65 and 70, and the frequency density is equal to 5. So let's go and plot that. So between 65 and 70, and the frequency density is all the way up here, which is 5, and then we go across and then back down. Your bars have got to join up together. That's really important. Really important. Okay. We then plot between 70 and 80. So from this part here, okay, with your frequency density being 3.6, let's go and do that. So this value across here, that is your value of, this is going to be 3.6 if you went across from that point there. Okay. And then last but not least, we've got our bigger interval, 80 to 100. So it's going to be going across here with your frequency density of being 1.2. Okay, if we go and plot that, there we go. And that is it. Right, I've drawn my histogram. And then, right, let's just go back to these key points here. Remembering the area of the bar represents frequency. Let's just double check that. Okay, if we go and find the area of, let's go and say this first bar here, let's use a different color so it doesn't get confusing. Right, if I go and find the area of this bar here, okay, let's call it bar 1. Right, well, for bar 1, right, it's got a width of that bar is 5 across, so 5, and the height of that bar is 3. So if I times these two together, okay, if I go and do, right, what's 5 times 3, area of a rectangle? It's going to be 15, right, which is my frequency, which is over here. Okay. Similarly, if I went and found the area of, let's go and say bar 3, the area of that bar should be equal to 36, and let's check it. Okay, so for bar 3, let's go and check that. It's got a width, a class width of 10, and the height of that bar is 3.6. So 3.6, and I've got this rectangle. Area of a rectangle is your base times your height. 10 times by 3.6 is equal to 36, which, there you go, is the frequency, how many people, remember frequency means how many people there are, which is 36, which is what I get from this area here. Okay, so that's hopefully giving you a bit more understanding, and that's really important to know for our next video where we look at actually interpreting a histogram. Anyway, hopefully that was useful, and on to the next video on histograms. Thank you.